Hello, my name is Justin Feralis, and today I'll be doing problem 12.58. So, a 3 meter long ladder leans against a frictionless wall. The coefficient of static friction between the ladder and the floor is 0.4. What is the minimum angle the ladder can make with the floor without without the ladder slipping? So, I already drew it, but I'm gonna like explain what each thing means. So, N1 is the force that the wall exerts on the ladder, and two is the force that the floor exerts on the ladder. The 3 meters is how long the ladder is. Um, Force of gravity, that's just pushing down on the ladder. Static friction, that's the coefficient, which is 0.4. And yeah, and then static friction is also pushing left, or that's what that means. Um, yeah, so it's moving positive, the positive direction, so going right. And the torque is going counterclockwise because if you're like if it were to spin, it would be going in a counterclockwise direction. Okay. And so to solve for the minimum angle, you need to remember or recall that the sum of the forces have to equal 0 due to Newton's laws, and also that the sum of the torques have to equal 0. And this is because that there is no angular acceleration and there's no linear acceleration. So yeah, so let's start off with the summation. So my y's are in red, so yeah, so we just take positive in the positive direction. So going up is n2, it's going positive, then minus mg, and this has to equal 0. So my n2 has to equal mg, just has to. And then for my x's, they're gonna be in blue. So n1 is going to the right in the positive direction. My static friction is going left in the negative direction. So just like the top one, these have to equal each other. So yeah. And then another way to write this is my n1 equals the coefficient times the normal force. Same thing as n1 static friction times mg. Okay, now for the torques, they have to equal 0 as well, but I have to explain each one. So the force of gravity is pushing down, and then to find the side that we need to be working with, we have to go perpendicular to the force. So this one is going downwards. So then to find how can I explain this? To find the side that we have to use, we have to go perpendicular. So it would be this side, and that would be adjacent to the side. So you have to use cosine. And since we're using only half of the triangle, we have to put L over 2. So we have to put the force, which is mg, times the lever arm, which is half the ladder, and times cosine theta, because that's the side we need. And then now we have to look at n1, because that's the other part of the torque. And then this one is moving this way, so we have to go perpendicular to it. So then this would be perpendicular to it. And then contrary to the other one, we're using the full arm, so instead of L over 2, we're going to use L. Also, yeah, so from this theta sign, this is the opposite side, so we have to use sine. So it's the force N1 times L sine theta, and this has to end up equaling 0. So to find the angle, we have to get sine and cosine on the same side, so it makes a tangent. So sine and cosine theta, which equals tangent theta. And then we have everything else left over. So a good thing about this is that the L's would cancel. So we're going to be left with mg over 2 n1. And if you recall from earlier, n1 is also the same as this. So your tangent theta equals mg 2 times the coefficient for static friction times mg. So the mg's here will cancel, and then you have the tan inverse both sides to get rid of the tangent here, so tan inverse. Just get rid of this, equals 1 over 2 the coefficient of static friction. So in my case it's 0.4, so 1 over 2 times 0.4, which is 1 over 0.8. And the minimum angle you need is 51.34 degrees to make it not slip. And thank you.